We've always been curious about the origins of the universe, or whether there is other life in our galaxy. Even as a kid, you've probably wondered what lies out there, amongst the cosmos. The James Webb Space Telescope may just be the answer to some of our most fundamental questions about space. Will it work? We don't know yet, but if it does, it will change the way we see space. Ready to be shocked? Continue watching to learn more about the Webb Telescope. First up, Hubble's successor. The Hubble was an engineering marvel when it was first launched into space. Sometimes we still come across a picture taken by Hubble and can't help but dwell on the magnificence of space. A classic example of such a picture would probably be the Pillars of Creation, or Mystic Mountain. Hubble isn't technically a small telescope. To see that far out, you've got to pack some power, right? The Hubble uses a single 2.4-meter mirror made of solid glass orbiting 340 miles away from the Earth. But imagine a telescope with a primary mirror spreading across 6.5 meters, with hexagonal sections coated with gold, all going together like a mosaic. That, ladies and gentlemen, is the James Webb Telescope we're talking about. It's the largest telescope ever built, and there's been a lot of debate, but in astronomy, size matters most of the time. The sheer size of the Webb Telescope gives a 6.25 times more surface area to capture light coming from distant planets, or in other words, the past. The James Webb Telescope basically captures infrared light. What does that mean? Well, it captures energy or heat. So, all that radiation coming from different stars and celestial bodies can easily be captured by the telescope. And that is what makes it so special, because those stars and celestial bodies aren't just ordinary stars or bodies. For starters, they are billions of light years away, dating back to the very early days of our universe. Next, a huge price tag. Now, we're sure you already know, the Webb telescope must have been really expensive to build. A couple of mirrors coated with gold are held together by some smart engineering work. $10 million or maybe $50 million, right? Seems reasonable. Oh, and you'd need to launch it into space too, about 1.5 million kilometers into space. So that brings it to a total of maybe 100 million or 200 million? Nope, the Webb telescope took a jaw-dropping $10 billion just to build. And to think that original estimates placed the construction of the telescope at $1 billion. But at the end of the day, it's justified. The Webb telescope is going to be giving us a lot of information about deep space. It might even explain the true details of the Big Bang and planet formations. And with such a huge price tag, Webb is 100 times more powerful and better than the Hubble, but also has enough fuel to remain operational for the next 10 years. We're going to be getting mind-boggling pictures of space over the next few years. Next, on its own. Remember Interstellar, that docking scene with the intense Hans Zimmer soundtrack? Yeah, that's not going to be happening if something goes wrong with the Webb telescope. It's 1.5 million kilometers away from the Earth at Lagrange 1, also known as L1. If you don't know what that is, it's just an empty point in space, or we can call it nothingness. But you're probably wondering how it could stay at an empty point when there's nothing to pull it. Like the Earth, for example, the Earth orbits the Sun and follows a path because the gravity of the Sun pulls it. But at an L1, there is no object like the Sun and hence no polar orbit. But this is where it gets really spacey. A Lagrange point has a very peculiar characteristic. It's sort of like a point of balance. Each time something starts falling down or moving away from a Lagrange point, it gathers some momentum, and that momentum pushes it back into a somewhat higher orbit than before. But anyway, let's not worry about that. The scientists and physicists probably did their homework before launching the telescope, so if something were to go wrong, the telescope would be lost. $10 billion floating in space just like that. A classic high-risk, high-reward situation. And so far, it's been rewarding. The telescope has reached L1 and took its first picture of a star. It's still in the calibration phase, so it'll take about 5 months before we'll be getting some clear images. Webb is on its own now. It's not in the Earth's orbit like Hubble. It's at a point where no man or spacecraft has ever been. Now, a wonder of engineering. Just like its predecessor, the Webb telescope redefined defined previous standards of engineering and telescopes. Remember when we told you the Webb telescope had 18 different hexagonal segments that would help it to focus? Well, those segments have small actuators on them. To keep things simple, an actuator is a device that can change its position. So, if things were to go out of position or the curve wasn't precise enough to focus on distant objects, the segments could adjust their position accordingly to precision fine, as 1/10,000th the width of a hair. Yes, you heard that right. 1/10,000th the width of a hair. And if that wasn't enough, the segments can also change their shapes to make sure the curve is precise enough to capture light coming from the early universe. When it was launched, the first 30 days were basically a gamble to see if the Webb would actually work. The solar panels had to come out really quickly so it had power. Then, over the next 29 days, a series of complex sequences took place, including the opening of the sun shields, and the mirror itself had to unfold. Looks like it paid off. Webb isn't just going to change the way we look at space, but it's going to change the lives of those who know the significance of this event. Just take a second to think about it. A group of extremely talented and dedicated individuals have just launched a device that can see some of the first luminous objects to ever exist in the universe. It's not just a telescope they launched, it's a time machine. And the information we're going to get will change everything. It'll change what's written in books about space. It'll change how we look at energy, dark matter, black holes, the Big Bang, and it'll also change life as a whole. Next, signs of life. The Webb telescope has one really interesting feature. It can help scientists understand the atmosphere of planetary systems. Say scientists found a planetary system like ours somewhere off in the universe. The system had a large object in the middle like our sun, and an Earth-like planet orbiting it. Now, depending on how far we're looking, it may just be the past. But by understanding the atmosphere of a planet, you can decode its complete chemical makeup, and that right there can actually reveal signs of life in other planetary systems. The chemical makeup of our home, Earth, is made up of a very precise chemical makeup made of methane, CO2, and a lot of other gases. Now, methane is also produced naturally by geology, but because of us humans, methane is produced in massive quantities. So, if we identified a planet out there with either a similar or very precise balance between CO2, methane, and the other chemicals, it could possibly help scientists narrow down the search for extraterrestrial life in the universe. So, just how many planetary systems are there in the universe? When you look up at night and you see a bright star, it isn't actually just another star. It's a planetary system because each star has at least one planet that orbits it. Even experts have no idea what to expect from the James Webb Telescope. Each time something has been sent up in space, we've learned something new. And believe us when we tell you, nature has always been much more imaginative than us humans. Who knows what we'll find up there? Maybe one day we'll be looking up at the stars and knowing that we're not alone in the universe. Or maybe one day mankind's finest will be preparing to become a multiplanetary species, having found a planet identical to the Earth in a far-off solar system. We know it sounds a bit too dramatic, but we are talking about the most powerful telescope ever built. We've come a long way. First, we used to look at stars from telescopes on Earth. Then we sent one into orbit. Now we've sent 1.5 million kilometers away from us in space. The possibilities are endless, and we have no clue what to expect this summer. The Webb telescope is being set up and optimized daily. We just have to wait a couple more months to see the unexpected. Even the people that designed and built it have no clue what they'll be seeing. That's it from our side, folks. What do you think? Will the James Webb telescope change the way we look at space and life? Do you think it'll help scientists discover the origin of the universe? Let us know what you think in the comments below. Don't forget to like this video and subscribe to our channel for more exciting videos in the future. Thanks for watching, and see you next time.